Thank you for joining this session. I am Grecia Castaldi from the Women Who Code Global team. Thank you for joining the Art of Efficient Data Processing using Pyspark and Dataproc with Samyukta Hariharan. I will read Samyukta's bio and then we will get started. Samyukta is a research engineer in data and AI at Arabesque AI Singapore. She has 3 years of experience working in data engineering and analytics. She revels in utilizing latest technology to build useful data, along with exploring its underlying value for investment use cases. When she's not coding, she enjoys writing, dancing, and golfing. So thank you so much, Samyukta. Over to you.
Thank you so much for the introduction. Hello, everybody. Thank you all for joining today's session. And today I'll be talking about, as the title says, the art of efficient data processing using Pyspark and Dataproc. Quite a long title, right? So let me just break it down for you first. The art of efficient data processing. Why do we need data processing and why do we even need efficiency? So it's basically the two images that summarizes it. The first image talks about how much data we had in this world as of 2021, especially in big data, right? And if you bring your attention to AWS, it had a total of 500 exabytes of memory of data stored within it. The Large Hadron Collider was producing 40,000 exabytes of data per year, which is a lot, right? It's not gigabytes, it's not terabytes, it's exabytes, not even petabytes. And if you look at the second graph over here, it shows the rate of growth of compute power as compared to the rate of growth of data. And as you can see, the rate of growth of compute power is linear, while data is growing at an exponential pace. We have so much data that we can leverage to do so much good in this world. But if we don't have the resources to process that data and make it into a format that is usable to us, that is usable to all the AI models that we are building and that the world is utilizing today, then we will be losing out on so much information and it would be quite a grim situation. So the need of the hour, and all this was as of 2017 and 21. So we are in 23 now. We don't even know if these two lines have crossed each other. But the need of the hour is to make our data processes as efficient as possible. And by efficient, I mean basically process more data with as less resources as possible. And that's the aim. The aim of this presentation is to introduce data processing and efficient data processing to all of you. Now, the second part of the title, which is Pyspark and Dataproc, jargon, right? But let me just give a quick introduction to all these terms. And I'll start with Spark. So Spark is a very, very popular distributed processing framework. It's used in so many places to basically deal with large amounts of data. And how is Spark different from our general data transformation tools like Pandas, right? Spark utilizes distributed processing. So basically, it uses in-memory processing. It will divide the tasks that you want to perform on your data into small chunks, and it will execute that over your memory, across your memory. And that way, a task that would be sequentially run would now be running in parallel and be much faster and can deal with much larger amount of data. And to perform this, Spark uses drivers and executors. So we have a master worker sort of an architecture in Spark, where the master node has multiple drivers and the worker nodes have multiple executors. And these drivers communicate with executors. And the user gives certain tasks to be performed on the data. Those tasks are split into small chunks, which are then executed across executors. And these tasks are assigned by the drivers. So drivers assign small chunks of tasks to each executor. And that's how it's all performed. I'll be showing you an image to make it a little more clear. But if you still have any questions, I would love to take it during the Q&A. And now let's come to Pyspark. So Spark was inherently built in Scala. Pyspark is a Python API for Spark. So you can run it on Python, use Python code, and build your Spark applications. And Dataproc is basically a Google Cloud service to run Spark on cloud. So Spark can be run locally as well. But if you want to scale it, if you want to assign more resources to your Spark clusters, then you can build it on cloud. And AWS and Azure as well have their respective tools to run Hadoop clusters on cloud. And for Google Cloud, because I've worked with Google Cloud, the tool that does this is Dataproc. A cluster is basically a virtual machine that would run your Spark application. So whatever I just explained, this image kind of summarizes it. So we have our Dataproc virtual machine. We have our master node and multiple worker nodes. And within the master node, we have drivers and we have executors that are communicated to by the drivers. So this is the summary. Now let's get to creating art. So the first and the most important thing is to be prepared, right? Let's ideate how to build an efficient system. We cannot directly jump into efficiency without understanding why and how much of efficiency we need to do. So if you're in a startup, especially, cost is such a big consideration. And so there may be a certain amount of cloud budget that you have allocated for a particular month, right? And so it's important to create a balance between how much efficiency you want to perform, which would, of course, increase if your budget is less and your data is more. So it's very important to kind of understand how much data you're dealing with, know your input data, understand the business logic behind what processing you want to perform, so that you are able to be able to figure out where you need to cut corners, where you need to make the process as efficient as possible. And all of this is indirectly related to cost, because at the end of it, when you're using cloud, when you're using resources, it all adds to cost. And so having that idea of budget is very important. And when you're dealing with tools and technologies, just have the documentations handy, be familiar with the tools and technologies that you want to use. If you're dealing with batch data, Spark is that tool. If you're dealing with streaming data, there's Kafka and other tools. So we need to have an idea of what kind of data, again, all interrelated, and what kind of tools we want to use for that data. And finally, just create a quick design idea of the code that you're going to be building for the processing. Now let's start painting, let's start discussing about the Pyspark code. Now, here, all this kind of brings us to the fundamentals of how Spark works. Spark optimization is endless, but this is just a quick beginning introduction to what we can do to leverage Spark's distributed processing framework. So one of the most expensive operations on Spark is joining two tables. Yeah, it's crazy to think about, but it is true. When you join two tables, the two tables are joined on a particular key. And on that key, these two tables are shuffled so much so that the rows kind of match in terms of the join key. And so at that point, it's very important to leverage the partitioning that Spark provides us, that the distributed computing that Spark provides us. So we can partition our data during read, during write, and even during processing in the memory. And for that, we can use something like repartition that will basically partition both our data sets. We can perform repartitioning on both the data sets on the join key, so that every partition is then shuffled. So we don't have to shuffle the entire data set. It'll be shuffled within each partition, and all the partitions will be distributed across the network. And the second thing that we should make sure that we do is understand what is the nature of the two tables that we are joining. So if there is one small table and one big table, then the small table can be broadcasted on the network. By broadcast, I mean Spark performs in-memory processing. So after every transformation, it will write to memory and read from memory. And what broadcast does is that it will take a copy of the small data frame and paste it on every single executor. So that way, only the large data frame will be shuffled, and that shuffling will be done according to the copy of the small data frame on each executor. So it makes the process much faster. But what if you're dealing with two large data frames, right? How do you can't broadcast one of them. So that's when something called caching becomes useful, because what caching does is that Spark works on transformations and actions. So a transformation is as simple as a select or a where or all these SQL operations, right? Uh, Operations that don't require an immediate result but can just be chained one after the other. But for the operations that require an immediate result, for example, a show, or if you are writing your data to disk, in those cases, you need to be able to see the data. So all the operations that have been chained in a lazy evaluation manner will now be executed when you call an action. So if you have more than one action within your application for the same table, then all the transformations performed on that table would be repeated right from start, right from start. So that's a lot of waste of resources, right? When you already computed it once, why do you want to compute it again? Just because I've called show once and I've saved the data the second time. So in that situation, caching the large table on memory after you've performed the processing and after you've written it one time, it's very useful, because the next time you write it, you will just have to read it from the memory and not perform everything from the beginning. It's important to look back at your work time and again. And by this, I mean, this is where you can leverage Dataproc, right? So Dataproc has got these dashboards and monitoring systems where you can monitor how the network is flowing in your cluster by looking at certain metrics and identifying bottlenecks. So, for example, if you want to identify any bottleneck between the communication between a driver and an executor, then the network bytes parameter would be very useful, because it would show you how much data is being transferred from the driver to the executor. Any spikes could be a sign of a problem. And also the input and output traffic, when you're reading and when you're writing, what is the traffic that is going that is flowing at that time. It's important to know when is it that the bottleneck is occurring. And for utilization of your resources, there could also be certain bottlenecks there. So how do you identify where your utilization is faltering? The first metric you could use is CPU utilization, where you're basically seeing how much of your CPU is being utilized. If it's at 40%, it's a matter of concern. 20 to 40% matter of concern. 70 to 80%, your utilization is still quite good. So that's something you can look at. And also the yarn memory. If your yarn memory is just constant and not going down, it's a problem. It should slowly start decreasing, and eventually all your jobs should be complete, and that's a sign of your yarn memory decreasing. So now I would just like to slowly end this presentation by talking about how you could utilize Google Cloud for more. So because I've used Google Cloud, I would like to highlight some advantages of Dataproc and also some other tools that have benefited me at work while using Dataproc as well. So the advantages of Dataproc are, number one, the low cost. It's just $0.01 per CPU per hour, along with additional costs of the VM. The clusters start up really fast, just 90 seconds to start a Hadoop cluster. You have something called preemptible nodes that have been personally very helpful for me, because when you want to not commit to a lot of nodes, let's say your job may require 12 CPU nodes, but you're sure it requires only 8. The 4 can be added as preemptible nodes, which are much less expensive, and they will only come to you if no other resources are using those nodes at the moment. So that is one very nice feature of Dataproc, and a very helpful dashboarding and monitoring system that you can modify based on the metrics that are helpful to you. And some other cloud technologies that can be used along with Dataproc are cloud storage, which would help in fast read and write and a flexible sort of storage mechanism, and cloud build, where you can create CI/CD codes to run your Spark clusters automatically, and again, very fast startup with the help of CI/CD. and Kubernetes engine, which is very interesting because it could be used as a replacement for Dataproc, where you can just create your own Spark application. That way, you get more autonomy for the resources that you're assigning to Spark, and basically more clarity as to how it's working on the back end. So you could also set up your Airflow jobs for orchestration of your Spark jobs, and that way, Kubernetes engine is a good alternative. That brings me to the end of my presentation. If you have any questions, I would love to take them now. And if you would, and I would love to connect with like-minded individuals over LinkedIn. So please feel free to connect with me. So yeah, thank you.
Thank you so much, Samyukta. We have one question in the chat. I will read it. So Divya is asking how Spark is different than Google Cloud Platform and Azure.
Okay, so Spark is not a cloud technology. Google Cloud Platform and Azure are cloud technologies by various companies like Google and Microsoft. Spark is an open source technology built by Apache. I mean, it's Apache Spark, and basically the contributions are by public, and it helps you with distributed processing of large data, whereas Google Cloud has got a multitude of other things that you can utilize it for. So, like storage and AI and other tools and technologies, whereas a very specific use case is what Spark does. Yeah, that's basically it.
Thank you so much. I hope that answered your question, Divya. Shaina is asking, can you explain the last part about Kubernetes again?
Absolutely. So Kubernetes engine is a way to containerize applications, right? So if you want to build your application on a specific operating system, then you can use Kubernetes, where you can assign certain resources to your cluster, and that would basically run as an end-to-end application. So what Dataproc is a managed cluster, which basically means that all the resources of Dataproc are managed by Google Cloud. But if you want autonomy on managing the resources from scratch for yourself, then you can use Kubernetes, which even Google has Kubernetes called GKE, Google Kubernetes Engine. So you can use something like that, which will help you create a Spark application from scratch on your machine and create like an end-to-end application along with some orchestration tools like Airflow. You can set up these open source technologies on your engine in Kubernetes, and you'll have more autonomy as to the how much resources are being used within that application. I hope that answers the question.
Thank you so much. Okay, we still have a few minutes if anyone has any questions. I have one question, Samyukta, if that's okay. Yeah. If you can tell us what are the pros and cons of using a managed service like Dataproc for running Spark jobs on cloud?
Yeah, so the pros are, like I mentioned, low cost, and very fast startup of the cluster, and these features like preemptible nodes, which kind of gives you that buffer, right? So that's the advantage of being on cloud, is that or being on Dataproc, is that you have all these buffer options and multiple options to choose from in terms of what machine you want to use and how many nodes you want to give and so on. But the disadvantages, I'd say it's a little restricting, and that's why I gave Kubernetes as an alternative, because it's a little restricting. You don't have entire clarity about how everything is occurring. So personally, I've seen situations where I'm running a Spark job and suddenly it's restarting, and I have no idea why, because the logs are not very helpful in that situation. So these restarts, all this would become very clear if you're running on Kubernetes, because you know what is going on in the back end. But with Dataproc, it's just a top layer, so it's not very transparent in that manner. Yeah.
Thank you so much. And is there a way to monitor the efficiency of Spark jobs on Dataproc?
Yeah, so Dataproc has a monitoring system, and we also have something called cloud monitoring, which is a separate feature of Google Cloud. So it's just stemmed off of that. You can assign your own metrics that you feel would be useful for you, and the monitoring system is very useful to basically see all kinds of input output trends and network trends and storage and CPU utilization and everything. So that's a very useful tool. Yeah.
Right on time. So thank you so much, Samyukta, and thank you everyone for joining.
Everyone, bye bye. Thank you.
Bye.